Hello, in this screencast I will demonstrate how to add semantics to a previously defined architecture. So far we defined interfaces and assemblies from a syntactic point of view. They have inputs and output ports. Inputs and outputs have data types. We would like to add semantics. Let's say for the sake of our demo that the sensor plausibilizer expects that the input value here, the raw value, is always bigger than 0. For this, I will create a precondition for this, that raw value is bigger than 0. I'm specifying this as a formula in LTL, Linear-Time Temporal Logic, very easily. So raw value is bigger than 0. Globally, this predicate should hold. Let's try to verify to check if our composition is consistent. I will check assume guarantee using NuSMV, and my assume guarantee check fails. Below the failure, if I'm double clicking, I get here the counterexample, and I can have a look why it fails. In order to get it easier to understand, we can simulate this counterexample, and I can step forward through the states of the counterexample. So basically, I see that in the second step, the value can be minus 73. Why is this? Because this raw value here comes via a channel from raw data from the top component, and we have nothing specified on the top component. So the top component has a type, my data type, which goes from minus 200 to 200. So it can be minus 73. I'm creating here a precondition that raw data is greater than 0. Raw data is greater than 0. And I'm rerunning. Now the verification passes, and we can go further. Let's say, for example, that the break activation works only if the precondition, it has a precondition, only if the sensor value is bigger than a certain threshold, is lower than a certain threshold. So precondition, I have a filtering here, say globally, my precondition is that the sensor value is smaller than a predefined constant here, my threshold, 50. I would like to check this. So running NuSMV, and now this precondition fails. Why? Again, because this data here comes from sensor plausibilizer, and it doesn't have any post condition. We don't have any semantics on this output data. Let's add one. So I'm creating a filter here which specifies that if raw value is bigger than threshold, then plausibilized value is my threshold, and here also my threshold should be. I'm rerunning this to see whether my architecture is consistent now. And it is still not consistent. Why? I could debug using the simulator. However, I know that in this demo I planned it, that we do not say anything here with this post condition what happens if my raw value is smaller than the threshold. So let's do this. I'm adding a new post condition, calling repeat, and modifying the formula. So globally, if raw value is smaller equal threshold, then plausibilized value is raw value. And I can perform the verification again. Here again, I have a failure, and looking at the model, actually I noticed that here I'm requiring that the sensor value is bigger than a threshold. However, I wanted to write smaller than a threshold. So rerunning, it fails again, and we can debug. So let's debug. I'm simulating again and looking attentively at what happens with this sensor value. So again, I'm starting from the beginning. That was too quick. And I see that in the first step, the threshold, the value of my input is 50, which is exactly like the value of the threshold. So basically I should have specified here smaller equal than threshold. Finally, now my architecture is consistent so far. Let's say that I have a requirement, a top level requirement, that whenever the input value is over 30, my system will produce a break. So globally, input value raw data is bigger than 30, then from the next step, in the next step, break will be true. And I can run again the check. And this time we have 3 conditions checked and the requirement is failing. Where should this logic happen? Should it be in the sensor plausibilizer? Most likely not, but rather in the break activator. So the break activator should decide when to break. Here I'm adding a post condition for this. Again, adding a name and specifying a formula. So globally, whenever my sensor value is bigger than 40, let's break. From the next state, in the next state I'm doing a break. I'm checking. And my formula is still failing. The architecture is not consistent. And if we look attentively at these conditions, we see a problem. So here I want to break at the top level whenever the input data is bigger than 30. However, my system breaks whenever it's bigger than 40. So we need to fix this to ensure that we break whenever it's needed. And we can fix it either by putting here 30 or by putting a value which is smaller than 30. So for example, 20. I'm rerunning the analysis and now the results are green. So basically the architecture is consistent. I've created here this example a bit more evolved, such that you can have a look and experiment with checking consistencies of architectures and simulating counterexamples in case of failures yourself.